Now we are going to prove the law of conservation of energy. For that we are considering a stone of mass m, at a height h. Then we are allowing it to fall freely under the influence of gravity, and it reaches the ground. So when it is at a height h, let its position be a, and when it reaches at a middle, let us say somewhat in the middle, in the position be b, and when it reaches the ground, the position be c. Now so the distance from a to c, and the distance or the displacement from a to c we can say as h. From a to b, let it be h. That means from b to c the displacement will be how much? H minus x. So from b to c the displacement will be h minus x. Now at position a, so when it is at position A, we are considering that and the body is at rest. That means the velocity at this position will be what? 0. So we can represent u is equal to 0. Now let us consider at B position the velocity of the stone be small letter v, and at position C the velocity of the stone, let it be capital V. Now we know that v square is equal to v square equal to u square plus 2as. So what we are going to do at b, we are going to find the value of v square. Why? Because we have to find the kinetic energy. So kinetic energy equation is half mv square. So we have to find the value of v here. V square here. So we are using the equation v square equal to u square plus 2as. So here S means displacement. Here S means displacement. So from A to B the displacement is x. So instead of S, what you are writing? We are writing x. And G, we are replacing A by G because it is falling under the influence of gravity. So we will have the equation small v square equal to u square plus 2gx. Now u is how much? 0. So we will get the value of v square equal to 2gx. Now at position C also we will do the same. Here we are taking, instead of small v, we are taking capital V equal to u square plus 2as. As here it is written gh. Why? Because a, it is the acceleration due to gravity. So we have replaced by we are replacing it by which letter? We are replacing it by acceleration due to gravity g. Now height. From A to C the displacement is h. So A to C the displacement is h. So we will write, instead of s we are going to write h here. So we have capital V square equal to 2gh. Why? Because u is equal to 0. So v square is equal to 2gh. So small letter v square is equal to 2gx, and capital letter v square equal to 2gh. So this we have to keep in mind for improving the law. So for that we are going to find the total energy at point A, point B and point C. So we are going to find the total energy at point A, point B and point C. Now at point A, what is the velocity? Velocity equal to 0. Now at point A the height equal to h. So for calculating the potential energy we have to know the height. So here at point A the height of the object is h. Displacement we have already discussed. So now potential energy is equal to what is the equation? mgh. Potential energy equal to mgh. So since the mass of the stone is m, acceleration due to gravitation is g, and the height is h, we can directly write potential energy of the stone at A is equal to mgh. Now we have to find the kinetic energy. So the value of kinetic energy equal to half mv square. Here velocity is equal to 0. So we have half m into 0 square, that equal to 0. That means at point A kinetic energy is 0. So at point A the body is not in motion, so the kinetic energy is 0. Now what we are going to find? We are going to find the total energy at point A. So the total energy at point A equal to how much? PE plus KE. That means potential energy plus kinetic energy, that is equal to mgh plus kinetic energy 0 is equal to mgh. So total energy at position A is equal to mgh. Like this we are going to find the position at B. Now at position B, here it is V square. Okay, so it is V square is equal to 2gx we have found earlier, and the height of the stone is h minus x. So height of the stone here from B to C, this is the height. So here the height of the stone is what? H minus x. Now potential energy we have to find with the equation mass into acceleration due to gravity into height. Here height h is equal to h minus x. So we will have the equation PE is equal to mg h minus x. So we will what we will do is we will multiply this mgx inside the bracket. So we will have the equation mgh minus mgx. Now we will find potential energy. Kinetic energy. Kinetic energy Ke is equal to half mv square. We have the value v square is equal to 2gx, that is equal to half into m into 2gx equal to, so this 2 and 2 cancels and we will get mgx. Now we have to find the total kinetic energy. So the total energy of the stone at B is equal to how much? What we have to do? We have to add this and this. So mgh minus mgx plus mgx. So this mgx and mgx will cut and we will get mgh. So the total energy at point B is also what? mgh. At A also it is mgh and at B also it is mgh. Now we are going to find the total energy at point C. For that we have here also V square is equal to 2gh. So what you have to do? You have to change here V as V square as 2gh. Then we have height. It has reached the ground, so height is 0. So potential energy will be how much? 0. Since height is 0, the potential energy will also be 0. And here the kinetic energy is maximum. So we have half mv square. So we know the value of v square. So it is 2gh. So half m into 2gh. 2 and 2 cancel. We have mgh. Now total energy at the point C. Total energy at point C is equal to potential energy plus kinetic energy. Potential energy is 0 and we have kinetic energy as mgh. So the total energy is mgh. That means at position A, position B and position C, the total energy is mgh. Here the sum of the potential energy and kinetic energy of object is same in all the three positions A, B and C, same. So here wherever we are taking at position A, if we are taking position B and position C we are taking, the energy is always same. So at a point A there is only potential energy, there is no kinetic energy. When it starts falling, the potential energy, what it will do? It will start decreasing and the kinetic energy will start increasing. That at point B, it is having both potential energy and kinetic energy, and again when it reaches C, the potential energy decreases to 0 and the kinetic energy increases to the maximum value. But whatever it changes, whatever potential energy is changing or kinetic energy is changing, the total energy of the system will be always the same. That means the energy is conserved in a system, whatever the energy changes take place. So this is how we are proving law of conservation of energy. Now we will go to the next point, power. So we are going to study about power. So what is power? So simply when we are going to do work. So if you have more power, you will do more work, isn't it? If you are having more power, you are going to do more work. Or if a machine is having more power, that machine will be doing more work. That means the fastness of the work also increases, isn't it? So if you are having more power, you will do the work more faster, and if you are less power, you are doing the work little bit slow. That means it is the rate of doing work. So what is power? Power is defined as the rate of doing work or the rate of transfer of energy. So when you are doing work, you are transferring energy. So when you are doing work, what you are doing? You are transferring the energy. So power we can define as what? The rate of doing work or the rate of transfer of energy. So what is power? Power is defined as the rate of doing work or the rate of transfer of energy. Now if an agent or if a machine or if any other thing is doing a work W in a time T, then the power is given by power is equal to work divided by time. So we said that the rate of doing work. Rate means always what we are dividing that particular quantity by what? Time. So rate of change of velocity. So that time velocity we are dividing by time. Rate of change of displacement. Displacement we are dividing by time. So here it is rate of doing work. That means you are dividing work by time. So if an agent is doing a work W in time T, then we will write the power is equal to work divided by time. So we can represent power by the letter P, capital P, and work by capital W and T by small letter t. So we will have the equation P is equal to W by T. Now the SI unit of work is what? Joules. Then the SI unit of time is seconds. So what will be the SI unit of power? It will be joules per second, or we are giving another name, that is watt. It is in the honor of the scientist James Watt. So we are commonly using the unit as watt. Now what is 1 watt of power? So we have to define 1 watt of power. So 1 watt is the power of an agent which does a work at the rate of 1 joule per second. So if a agent or if a machine is doing a work per 1 joule per second at a rate of 1 joule per second, then we can call that agent is having 1 watt of power. Or we can say power is said to be 1 watt when the rate of consumption of energy is 1 joule per second. So we can also say that the power is said to be 1 watt when we are consuming 1 joule of energy per second. When we are consuming 1 joule of energy per second, then we can say that power is 1 watt. So now some other units are also used. Kilowatt. So some of the time we are using kilowatt. So 1 kilowatt is equal to how many watt? 1000 watt. Now for some machines we are using horsepower, HP. So 1 horsepower is equal to 146 watt. So whenever we hear the word 1 HP, that means it is having 746 watt power. Now we are to learn what is average energy. So the power of an agent will vary with time. This means the agent may be doing work at different rate or different interval of time. So sometimes we will be doing according to our energy, the rate of doing work will be different. Sometimes we will do faster work, sometimes the work will be slower at different interval of time. So we are using the concept of average power. So what we are using? We are using the concept of average power, and we can obtain average power by dividing total energy consumed by the total time taken. So what is average energy? It is the total energy consumed divided by total time taken. So we can obtain average power by dividing the total energy consumed by the total time taken. Now the last part of our portion, commercial unit of energy. So the unit joule is very small and we cannot use it for expressing in larger quantity. So we are having inconvenience in using the unit joules sometimes. So we are using a bigger unit. So we are using what? A bigger unit. So you have noticed in your home that there will be a meter kept for knowing how much energy is consumed, electrical energy is consumed. So we call it as kilowatt hour, isn't it? In that it is written kilowatt hour. So we are using most of the time for expressing the energy unit of energy as kilowatt hour. So we are using what? Kilowatt hour. So the unit joule is so small, and hence for expressing larger quantities what we are using kilowatt hour. Now what is 1 kilowatt hour? So when you are using 1 unit of energy, then how much joules of energy you are using, so that we are going to know. So 1 kilowatt hour is the energy used in 1 hour at the rate of 1000 joules per second, or 1 kilowatt. So what is 1 kilowatt hour? So we are using the energy. 1 kilowatt hour is the energy used in 1 hour at the rate of 1000 joules per second. So we in 1 hour, if you are using 1000 joules per second, then we are consuming how many kilowatt? 1 kilowatt hour. Now 1 kilowatt hour is equal to 1 kilowatt into 1 hour. So 1 kilowatt is equal to how many watts? 1000 watt into 1 hour equal to 60 into 60, that is 3600 second. So equal to 1000 joules per second into 3600 seconds. This seconds will cancel, and we will have 1 kilowatt hour equal to how much? 36, then we have 50 joules. So we are writing in short form. So what we will do, we will count how many zeros are there, plus 1 6 also we will take it. Then we will write 3.6 into 10 raised to 6. 3.6 into 10 raised to 6 joules. So 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. So this energy we are using in household industries and commercial establishment. We are using this kilowatt hour for expressing how much energy we have used. So whenever whenever our meter is saying that we have used 1 unit, that means we are using 1 kilowatt hour of energy. So in the meter, when you are saying that you have used 1 unit, that means you are using 1 kilowatt hour of the energy. So this is the things we have learned in this chapter. So first thing what we have studied, what is work. So what is work? Work done on an object is defined as the magnitude of force into displacement. So it is the magnitude of what? Force into displacement. Then we studied what is the unit of work is joules. Then we studied what is energy. Then it is the capacity to do work. After that we studied about kinetic energy and potential energy. Then we studied law of conservation of energy, and in the last part we studied power. So these all are the things what we have to study in this chapter. Hope you understood. If you are having any doubt, you can call me, or from the next Monday onwards we will start our classes. There we can discuss.